Hey everybody, it's Jay from Norman S. Wright. I realized after I did last week's video on fan selection at altitude that I've never really discussed fan selection, so I want to do that today. So let's get started. Picking the right fan isn't just about matching CFM and static pressure. It's about understanding the entire system and how the fan will operate over time. It all starts with how much air you need to move and how much static pressure you have to overcome. The static pressure includes your ductwork, filters, coils, and everything that adds pressure drop to the system. Let's move this up a little bit. If your fan produces 5,000 CFM at 2 inches, but your system has a pressure drop of 2.5 inches, you basically have no pressure left at the end of your system, meaning no airflow. So let's move this up and look at a fan curve. So airflow is along the bottom and static pressure is up the side. The red line is your fan curve. As you move to the right, you're getting more airflow but at a lower pressure. The blue line is the system curve. The system curve is a graph that shows the total pressure required to move a specific amount of air through the entire duct system at different airflow rates. Where the system curve intersects the fan curve is where your fan will operate, which is 5,000 CFM and 1.5 inches of pressure here. This is assuming the installation has not introduced any system effects that would increase the system pressures. I've done a video on system effects, so I'll link it below. This shaded area on the left is the stall or unstable region. You can see that around 2 inches of static, there are a couple airflow points on the fan curve. So will the fan operate at 2,000 CFM or 3,000 or maybe 3,500? If you operate there, the fan can surge, vibrate, get noisy, or even cause damage to the fan components. So we want our design point to be well to the right of that unstable region. You can also see on the fan curve that at our operating point, the fan is operating at 1074 RPM. Let's move this over for a minute. Here's another fan curve that I showed last week. It shows the fan operation at different RPMs, and our operating point is right here. So if nothing changed in our system, you can see that when you speed up or slow down the fan, the CFM and static pressure would change. Let's move back over to the other curve. The fan curve will also show a brake horsepower curve. Brake horsepower is the actual horsepower needed at the fan shaft to move the air against the system's resistance. For this fan, our brake horsepower is about 2.2 horsepower. Let me copy this and move it to the top to make some room here in the middle. The motor horsepower you select must meet or exceed the fan's brake horsepower. Let's make a little bit more room. You want to select your fans so that your operating point is near the best efficiency point. This is usually the upper 2/3 of the curve, but well clear of the stall zone. This is where the fan runs smooth, quiet, and is energy efficient. Let's bring everything back on screen. So that's the basics of fan selection. If you have any questions or suggestions for future videos, put them in the comments below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.